Good morning, all.
Good morning, sir.
Good morning, sir. Good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
I request our principal, sir, Professor P.K. Patil, to deliver the inaugural address and thereby inaugurate our second FDP. Over to you, sir.
Thank you very much, sir. Our revered HOD MC department, Dr. R.K. Das, our associate professor, Dr. S.K. Joy Singh, all the faculty members of IMIT Kotak, our revered invited speaker of the session, Professor Nagappa U Bhajantri, all the delegates present in this FDP. I extend a hearty welcome to all of you to this FDP, which is organized by IMIT Kotak and supported by BPUD Odisha. This program is the second in the series organized by IMIT. IMIT is a very old institute in our state, which was established in 1962. This college is a constituent college of BPUD Odisha, and it is under the administrative control under the Skill Development and Technical Education Department of Odisha. I am happy that many delegates from different colleges under BPUD have joined this program. And at the outset, on behalf of the university and on behalf of the institute, I extend my thanks and appreciation to our revered invited speaker, Professor Nagappa U Bhajantri, Head of the Department of Computer Science and Engineering, Government Engineering College, Chamrajnagar, Mysore, Karnataka, for his kind acceptance to join as an invited speaker in this program. And really, we are very much thankful to you for your kind consent to interact with all our delegates today. Really, it is a proud privilege for all of us. These type of programs are organized by our university regularly, at least once in a month, for our teachers of not only computer science department but also other departments also. Our speaker, Professor Nagappa U Bhajantri, he will address today on the topic some novel approaches to object tracking, which is a very important topic and advanced topic. So he will address all our delegates, and maybe last 20 minutes he will interact to answer the questions, if any, by our delegates. But before we invite him to address, I request our head of the department, Dr. R.K. Das, to have brief introduction about our today's speaker, Professor Bhajantri. Thank you very much.
Sir.
Dr. R.K. Das, our HOD, will introduce our speaker now. Hello, Dr. Das.
Thank you very much, sir. Respected principal, sir. Respected revered speaker for today, Professor Nagappa U Bhajantri. Respected Associate Professor S.K. Joy Singh, Swami Babu, and all the participants. Thank you for your support. And last time we did approximately 80 participants joined, and now 42 has joined, and I hope the attendance will improve. Thank you very participation. Thank you very much for your interest. Now, taking the opportunity, I must thank BPUT for selecting IMIT as the nodal center, and we have been interested to conduct this FDP once in a month. So, taking this opportunity, first of all, I must extend my heartfelt thanks to Professor Nagappa Bhajantri, and let me introduce. He is very renowned person, and his interests are pattern recognition, image processing, feature reduction, cluster analysis, object tracking, and music information retrieval. He is a very much prominent professor all over the world in the field of computer science and engineering. He has been chaired different national and international workshops, and uh, uh, he is in the curriculum revision committee of PG and UG students in computer science and engineering and information technology. He is the coordinator of BE, MCA, and MTech programs. He is credited for creating the developing database management system course, Help Manual, currently being utilized by over 200 users for BCA in Karnataka Open University, Mysore, and he has served as board member at VTU, BEC, Bagalkot, and PDA Gulbarga. He has guided 5 PhD students successfully. Now he has delivered a series of lectures, data structure at VTU EduSat program, Bangalore. Now, as for his education, he has done BE in computer engineering, then MTech from IIT Delhi, and PhD in image processing and pattern recognition of University of Mysore in 2007. Now, he has received many awards. Now, some of the awards are awarded. He has been numerous times awarded as Best Paper Award. Then he has, to his credit, patent. The patent is IoT-based virtual students monitoring system by using TF plus mini Linda sensor. So this is the pattern, and he has got many publications to his credit, and he has also received research funds from different government agencies. So thereby, as you see, he has very vast experience in computer vision, image processing, and today he will take us to the exciting and wonderful world of computer vision, then object tracking. Object tracking has always been fascinated me. How the computer can track a particular object, especially in moving scenario. So that has been, for me, it has been a wonderful and exciting field. So I am sure some of our the participants will be exposed to the exciting and wonderful world of object tracking, and who knows, some of you may be excited to take research work in this field, because these days everything belongs to the computer vision and object tracking. Now in Odisha, now recently we are forced to change the number plate of vehicle to this high security number plate. This is also part of the object tracking thing, for which we have to undergo the number plate change. So I am sure sir will take us to this wonderland of object tracking, and we will plan our FDP like this. Sir will be delivering, and please, in order to make it interactive session, you please keep track of the questions, or you can type the questions in the chat box. I will be keeping track, and in the last 30 minutes probably we will have question answer session. Or if sir agrees, you can also put questions, because monologue will not actually serve the purpose, and I want that all the participants should actively participate and put their questions so that it will be interactive and it will be useful for us. Thank you very much. Thank you for your participation. Thank you, sir, for agreeing, and thank our principal, sir, for guiding us in making this, in organizing this FDP. And taking this opportunity, I will also thank the representatives of BPUT, the Nodal Center, who is in charge of the FDP program. They are also there here, and without their cooperation, it could not have been possible to organize the FDP. Thank you all. Now, I request our revered speaker, Professor Nagappa Bhajantri, to take over the case. Over to you, sir.
Okay, sir. I am audible, sir?
Yes, sir. You are
audible. Okay, sir. At the outset, I got an opportunity to share my little laboratory efforts. At the beginning, professor and principal of IMT Katak PK Pari, and subsequently I am followed by the HOD Rai Guru Akshay Kumar Das. Somehow we came in a contact and especially that from BK Patnaik, professor. We came to know each other. Then we extended to the ITMT also. Here I am going to be discuss some of the topics which may be related to computer vision and artificial intelligence. So I will go to slide, sir. Hello, sir.
Yes, sir.
I will go to screen.
Yes, sir. You can share this slide. Yes, sir. It is visible.
Is it visible, sir?
Yes, sir. Visible.
Definitely, this talk will be helpful for most of the who has budding researchers, or they have a plan to start research, especially in a computer vision and image processing and etc. Here I am going to be talk about the tracking process, object tracking process. So in the process, we may be required some little mathematics. Definitely, without mathematics, we may not get interest, or we may not get the precise results. That is a backbone for especially this computer vision. So my presentation flow, I will start with some introduction. How this is taking place, and what are the milestones we need to be crossed, and what are the terminologies we should be have, and what are the prerequisite the knowledge should acquire, etc. And basically, this is a course related to the machine intelligence, or computer which perform in the absence of the human. Research efforts with the results. I will exercise some of the research experiments. For those outcomes will be there. So those outcomes I may be interested to share with you, right? Similarly, it may enhance your interest towards the kind of topic we want to take up as a the further study. Also, I am going to be establish the analysis, how this particular X algorithm is supreme, how this Y algorithm may hinder the performance, obscure the some of the data and so on. That obviously we can derive some of the research topics from this, uh, and there are some of the outcomes in terms of some of the papers may be published in some of the publisher. There is also definitely we can see that. I'm coming to the before going to the object tracking, we can touch upon some of the circumstances or circumference area, which one is artificial intelligence. You can see that the machine, uh, any machine which want to perform some of the tasks without interference of the human beings. In other words, that problem or that model should acquire some of the knowledge and take a decisions after doing some computations. It has to take some decisions and help to the human beings for the various work uh, without intervening the human beings. Machines should learn themselves and assist to the human beings or industry or any of the tasks which will be performed in the automated area. Automated area. That is a artificial intelligence that we have been enjoying in a daily life, maybe phone, maybe our market shares, maybe car, maybe our the industry various applications. So these are all the emerged from the artificial intelligence, right? So that has to acquire a knowledge, has to be process that knowledge, and that knowledge we can use for the decision making, right? So after decision making, it has to be activate that work. Once got the data from the sensor from the ground truth, so those would generated and converted into, it may be unlocked digital, or it may be readable form and into the standard form, which may be placed in a knowledge base. So that knowledge base could be a digital knowledge base. So that kind of a cognition. Once we observe some particular object or particular environment or particular event, after that we may capture some of the information. That information will be going to be converted into digital form, putting into the knowledge base. So cognition, cognize the object. We can understand the object. Once the cognize, then we can, that is kind of a training happen. So training means it acquire the necessary data which yeah, which is visible at the vicinity of that sensor or that whatever the device which will be located there. So after acquiring that, it will be convert them into digital form stored in a database called knowledge base. That is a cognition. That is a training. Once the training over, we can start the testing. We can start the testing. That is a recognition. We can take the data from the knowledge base. We can convert them into the sentence, word, or actions. Sentence, word, or actions, which will be useful for the human beings or from the or for the any industrial applications. So that is called a recognition, or we can say testing. So this is a kind of mechanism will be happening. So basically this artificial intelligence will be expanded in a various way. Maybe that is a narrow intelligence or mere deep intelligence or maybe general intelligence, right? So these may be normally classified. We being a computer science engineers will be see that artificial neural networks. Artificial neural networks is also kind of a artificial intelligence will be fit to the machine to perform, as I told in the previous discussion, that is a cognition and recognition, training and testing, right? So it will be keep happening in the process. So after seeing vision is also one of the branch of that artificial intelligence, right? Computer vision. So computer vision, which will be, as we said, that it will be occupy the some of the information through the camera, through the sensors, through the some of the electronic devices, which will maybe robot, which will be capture the data. That data we can maybe a video. We can call it a video, right? So that video is a set of frames. Video can convert it into frames, right? Frame is a photo. Photo is a image. In our mathematics, we will call it a matrix. Photo, frame to photo, photo is an image, image is a, we can call it as a, in our mathematical model, we can put an image into mathematics called matrix. So matrix theory, we may be very well known as being an engineer, we may be understood thoroughly that. Once we brought into the matrix, or it is a frame, so there we have a information, right? So that information we need to be compute, manipulate, we can relate, establish some relations, right? So that we have a spatial features or frequency features. So all those the features we can encompass over them, and we can easily make it to knowledge base, right? So in that sense, computer vision, maybe you can see that segmentation algorithm, you can see reconstruction of the images. So you can see some of the image model, image enhancement techniques, right? So these are all the part of the computer vision, right? So after seeing this computer vision, so we can see that enormous applications as we have been enjoying in a daily life, controlling a process, right? So you might be seeing that CNC machine, or you can see that some of the confectionery factory, or you can see some of the factory which may be manufacturing the product, maybe water or maybe various components. So there is a lot of controlling mechanism will be happening. So there is a multiple cameras are there which will be acquire the specimen or the data, which will be maybe stationary object or dynamic or moving objects. So that after acquiring them, according to the pre-described algorithm, it has to control some of them. Similarly, the autonomous vehicle. So nowadays we can see the driverless vehicle. So nowadays we can see that the smart vehicles, which have multiple cameras. Again, we have ABS. We can have the lot of improvement over the automotive vehicles, which will be completely controlled by the most of the microprocessor or microcontroller, which will be study the traffic lay fixation, lay fixation. So that fix into the particular lay, then it has to be proceed, and also follow the traffic rules, following those, and we can provide the justice for the who doing mistakes or crimes. So similarly, the indexing of images, we can see today's smart search engines. Maybe popularly we are no, or we have been using maybe Google or Amazon or maybe lot many search engines we may come across. So there is a smart the classification of the images or videos, or there is a intelligence in learning based on the input given by the user. That based on them, that will be scholarly supplying the data to the who are interested to observe or search some of the information into the in the website. Modeling object, right? So we need to be model the object. Some of the dangerous areas may be nuclear fission or nuclear reactor or some of the pharmaceutical company. So there we need to be model the objects. So of course the mechanical the machines are doing that. So some intelligence will be added to or value is added to those machines by this computer vision algorithms or some of the other IoT algorithms. There could be automatic inspection. You might have experience in the industry that is a second classification, especially granite or tiles, or most of their automatic classifications will happen. There is a scene construction, reconstruction is also there. There is a partial scene, that scene we can reconstruct to compare with the original as we and it happened in the destroy cases. Image restoration, we can restore the image for various other applications. There is also event detection, motion estimation also going to be discussed. So object recognition, as I told, that is a cognition and recognition. After cognizing and recognizing, we may get a database. From that database, we can see that that is a database related to the object. Maybe a set of animals, maybe a set of geometrical shapes, maybe a set of oblique shape objects. So based on that, we can extract the features and we can put it to the database that may be helpful for recognition of the object. Eventually, object tracking. So the we can as we see that video sequence into frames, frames into images. So image we have some objects. There is a photo or image. There is a one object. So object may be regular shape, irregular shape. Object may be rigid body or non-rigid body. So object may be parametric motion or non-parametric motion. That we'll see in the subsequent discussion. At this junction, we can see object, right? Once if the object is there, so that object which may be displaced, which may be changed its place with respect to time, right? With respect to time. So the frame 1 is a time 0 if you assume. Frame 2, it is a time time t1. So there is a object, there is a difference between frame 1 and frame 0 is a some value will be get that may be 0. If it is 0, there is no motion of the object. There is a change in the change of place of the object. So if it is there is some value, the difference will be some value, absolute value, then we may get in some evidence there is a object movement will be happening. So such objects will be keep moving. So we can identify that. First of all, we can identify the object. Then secondly, we can trace that motion, trace their change in place, right? So that change in place identification is also going to be very important. Means so that should be that should not be a drastic displacement. That should be maybe a smooth displacement. Maybe it should not go out of the frame of reference. It should not go beyond that image area, right? If it is goes, then it may be difficult to trace out. For which the camera will look after to put it into in the area of the frame. That will be discussed in the subsequent discussion. So tracking of those the displacement of the object is the same that will be followed in length in the subsequent discussion. So for which we have to take the algorithms called basic algorithm, the pattern and image processing algorithms. So this kind of algorithm is going to be extended for this abstract this track of the subject. So there is plenty of objects, the applications we have been saying, that is, as I told that is a automated industry which may be with help of the robot navigation. So robot should understand the object should be within the frame of reference. The camera of that robot should fix that object within the frame of reference. If it is the object is moving, that robot is also moved. So that movement or motion has to be predicted here. So that motion has to be predicted here. Either we can predict by building a model, or we can compute the trajectory of that object, right? So similarly, there are several industry applications we have being said, that is, maybe in our daily life we can see video surveillance, CCTV, right? So that CCTV is a camera is a fixed. That is a camera is a static. The background is a static. But the several objects are coming and going in the frame of reference of that camera, right? So only those objects will be captured by that video, the surveillance camera. So we want to more accurate, for which we can go for multiple cameras. Multiple camera means we can hold the multiple backgrounds, right? So that multiple breadcrumbs, the same objects may go to the camera 1 and other camera 3 or vice versa. So those we can rejoin those backgrounds, so we can able to give some justice for that any mistakes happen or maybe any some of the applications. It depends upon the applications. Most of the time we can find out some crimes which will happen. We can able to understand by this CCTV camera. Also, traffic monitoring, as we discussed the earlier discussion, that is a unmanned vehicles. Today, the smart vehicles which will be fix their lane while traveling and follow the traffic zones and various hurdles they have to face, and that completely the automated vehicles which will be transport for the transport of the humans. Similarly, that entertainment media, so that is a tremendous, enormous improvement happen. We have been enjoying in the by observing the films, and especially that medical imaging, right? So medical imaging, you might be see that most of the radiologists, which they create the uh, portion of the portion of the organ of the human body. They create some images in order to understand the disturbance or some of the inspection happen in the human body. So after creating them, they will analyze in order to diagnose the what is the problem or medical suggestions they want to provide. In that they will create the partial images of the human organs, right? So that could be possible. You might have been enjoying or experience might be a MRI, right? So maybe function MRI, maybe X-ray, right? Maybe ultrasound images, right? So maybe ECG, right? So several the some sub portion of the human body images have been created to understand that the disturbance which happen in that organs by the most of the medical practitioner, especially radiologist. So armed forces. So you can see that there is a, you might have heard that space guard, space guard. The space guard, which will be definitely watch the earth object, which might have some occur some disturbance from the other similar bodies. So for that, there could be definitely the lot of the tracking and computer vision will be involved there. So they will be advancedly predict that any body is hitting like that. Maybe army, maybe maybe air force. So maybe army, you might have heard that there is a camouflage net. There is a camouflage net. Most of the Western country, developed country, they have been using the camouflage net. Means the green net. The green net is will be spread across the above 1 kilometer of that approximately above the military army camp or army camps, so that the enemy satellite can definitely obscure or failure to identify that the defense, the some of the organizations which will be established at the ground force. So that like that there is a lot of camouflage which will be happen. That's why there may be greenery and most of the colors they are using, that is so that enemy satellite definitely failure to identify them, that is. So there is also, you might be heard, thermal camouflage, right? So most of the weapons which will be heated produce the heat, for which that is a heat resistance will be used, so that it will be unidentified by the enemy satellite. So similarly, law enforcement, right? So which you have a lot of today's we can see that have been computerized, and most of the artificial intelligence have incorporated, and we have been enjoying most of the result in a ready forum. So these are few applications, will not be limited to here. There is also tremendous applications have been observed in the industry. So some of the after knowing these applications, so let me see that how tracking will be happening, right? So before tracking, we have seen that cognition and recognition, training and testing, or with the help of the knowledge base, right? So that video sequence in here the discussion will be commenced with the video frames, right? So that video frames, we have n number of frames. Maybe Indian cameras we have 28 frames per second. most of the Western and US camera 32 frames per second, right? Each frame which have resolution and quantization. So the resolution and their pixel intensity. So number of pixels you might be heard. The today's mobile, maybe we have 10 MB, 10 MP per 10 megapixel or 20 megapixel. So that is a 10 into 10 to the power of 6 or 6 number of pixels per inch by inch area. The resolution, more number of pixels. What is a pixel? Pixel is a light intensity. That is a source of the light, right? So those pixels, number of pixels will be more and resolution will be more, right? Nature have infinity resolution. Our electronic instruments have the quantized one or limited, finite one. So we need to be convert that analog to digital, put into the instrument of that camera, or we produce the videos. So and also that the pixel intensity will be measured. Maybe black and white is 0 and 1, gray image is 0 to 255, RGB is a 3 component 2 power 24, that is a red 2 power 8 for red, 2 power 8 for green, 2 power 8 for blue, similarly 2 power 24. So those number of the values is required to store that pixel intensity and so on. So once you understand that image comprises the object. So we need to be identify that object could be by exercising various the features. So you can exercise some features. So those features will be collected by the based on that texture, based on the boundary, or based on that appearance, or based on the various factors. So we can collect some features. So we can put the object features, and those features will be there in the database. So we can compare them, and we can decide based on the threshold, based on the exact matching. Exact matching may not possible. To the approximate level matching, we can go that, right? So that will be either perform frame difference, optical flow, background subtraction. Will be discussed in the subscript slide in detail in the further explanation. Then once we identify the object, that image might consist of several objects, right? We need to be classify them. Which objects maybe I am interested? Maybe object scene maybe consist of maybe bottle image, maybe pen, maybe paper. Sorry, maybe some maybe ball or something, right? So there are several objects may be possible in the photo or in the frame. So we need to be classify them. In order to classify them, we can exercise maybe supervised classing or unsupervised classing. Supervised classing, we know very well about that the objects. So once we know that object, then the is that object is there, and like that the matching will be happening. So exact matching or approximating, which will be take a threshold. So which our threshold have a maximum value, we can fix, that is based on threshold we can decide this object I am interested, and that object we need to be identify. In order to identify, then we have to allocate the unique ID, right? So this classification we can perform by either texture based, color based, so on, shape based, motion based. So on. That is, once you classify that we are interested in the particular object, so that object will be named by some ID. So that once it is identify them, and we can put some bounding box over that. Means that is the object. In the scene there is several objects, or in a photo there is several objects. So particular object we are interested, over that we can put a box, maybe a square box or rectangle box or maybe triangle box. So it depends upon that whatever that interest, right? So normally most of them put is a rectangle box over that object. So that is a one kind of identification of that ID. Once it is identified, so that we can achieve this tracking, right? We need to be track them, or we need to be understand that motion where it is go to in the next frame, right? So that point base which could be happening, that is, so that it directly operates on the point. It directly operates on the pixel. The pixel which is present in the current frame, and where that frame is there in the next frame. We need to be establish the relation between the frame at the particular frame, point at the particular frame, where that point in the next frame. So there should be some relation. So that relation we need to be understand with a point-based algorithm. And also the second method is a kernel-based method, which is a kernel we need to be built, some model we need to be built, right? So this kernel model we need to be help to trace that is a object where it is moving. Similarly, seal-out based mechanism. Seal-out based mechanism, definitely it will be look for the non-rigid objects, maybe face, maybe some of the moving objects, non-rigid objects which will be coming in a frame of that reference. So there we need to identify them by the seal-out. Seal-out majorly looking by the shape we need to be extract. So to extract the shape, several mechanisms are available in the image processing techniques. So those techniques we can exercise and we need to be find out that shapes. And another method we can also find out the contours, right? Contours or signatures, so that some of the partial information we get from the contour mechanism. So with help of this, with a connected component mechanism, we can easily establish the relation between the object which is present and also where it is present in the next frame. So this point tracking, kernel tracking, seal-out tracking, we have seen that the directly pixel will be operated, which is present in the first frame and the next frame, what type of relations are with statistical relations or some frequency relations we can exercise. We need to be understand the exact relations. So with help of that relation, so we can go for the finding the tracking that object. Kernel tracking, that is a model based one. So that will be definitely which will help for most of the concepts you evolved here. So that will also going to be discussed in the subsequent. Seal-out, as I told, that is for rigid one, and the Kalman filter is a point one of the example. Particle filter, which understand the dynamics of the points which is moved from one frame to other frame, right? So the dynamicity of that particle, point, the dynamicity of the points. Points means the object, right? So object might consist several points. I may talk with one point or bunch of points. So that the dynamicity of that points from one frame to other frame, so that will be deal with a particle filter. Some of the algorithms. There is also the hypothesis mechanism or exercise. There are to establish the motion need to be understand where it is moving from one frame to other frame or within a frame it will be changed. The simple template matching, the kernel tracking is a kernel mechanism is majorly suit for that is what we call it as the parametric motion. So parametric motion, we know that the object may move towards the x direction or y direction, right? One more direction, third dimension, that is a z direction. So there is a parametric motion. The object may move in all three directions. So in that case, the kernel tracking mechanism are more suitable. The simple the matching, template matching. So we can build a templates. Templates we can build, that is matching template and that existing template. So those will be matched with some threshold. So it may match. You can consider them as a path. And also mean shift method. So you might be see most of the time they will exercise, especially in a spatial domain. They might be exercise some of the brute force techniques to acquire the features of that object, right? Brute force technique to exercise to trace that displacement of the object in a scene or in a frame. So that may be some of the may not tangible. So highly complex, computationally complex one. It may go more than non-polynomial algorithm, non-polynomial. That is become very huge computation for the machine. For that, they will go for histograms, right? So histograms is one of the techniques they will exercise to understand the similarity of that object movement, motion object. That is a mean shift. And also support vector machine, we might be heard that. So that that will be separate that hyperplane. Some of the maybe when you especially classifying that the data or objects, so some of the objects may not belong to any class, which may outlier some of the borderly fixed, that is, so that high accuracy we can obtain, that is a support vector machine. That will be a very old technique which will be still people have been employed to discriminate the object when it is in a motion. And also layer based tracking also there is a several steps will be involved in that technique will be there. And the silhouette tracking, you said that is a non-rigid bodies which are there in a scene. So such objects can be identified with the help of the contour matching. Contour matching, so that is a contour or signature, so that we can compute that. And also shape matching, so that is a shapes are there, so that shapes we can obtain with help of the morphological operator. We'll get the animal shape, we'll get a object, any type of regular object, irregular object. So for that we can obtain the shape. There is a huge database is there. That database we can borrow that. So after going this, we can have a lot of hurdles. We can have a constraints here. It may not so easy because human visualization is highly appreciated. Human have highest power to visualize and trace the motion of the object in a scene, or sometimes it go beyond the scene. Here we have restricted to frame of reference, the camera which is posing to the particular object, so that stationary objects or movement of the objects. Keeping on this mind, we can see some of the hurdles which have need to be faced, right? Image corrupted with a noise, right? Image, as I said, it is a frame that is drawn from the sequence of the video, sequence of the frames. In other words, that is a video. So image corrupted with a noise. So you can see that noise is a part and parcel of the whatever the information, right? So sometimes this we can call as unwanted electric potential. It may contribute or may not contribute. Most of the times it may never contribute to as a information representation. So noise, you might be seen that or maybe heard the lot of noise mathematical models are there. They have perfectly classified in the literature. You might be heard that one such noise called Gaussian noise. So Gaussian noise, which will be when you see that where the source of the video. The source of the video may be camera most of the time. So camera might consist several sensors. Sensors is again a mathematical model, right? So these sensors have a circuits, right? Sensor circuits which due to their mathematical model, due to their mathematical model, sensors might contribute due to the illumination. Due to the illumination, that the light intensity changes over the object during the certain period. So that kind of environment which will be misguide the sensors. So sensors would unable to capture the videos, right? Due to that sensor circuits, it definitely produces noises called Gaussian noise. You can also heard there is a one more noise called salt and pepper noise, right? Salt and pepper noise. You might be heard that. See this again. We go to the bottom of this knowledge where the video will be captured by the device. So those device which will be practiced or adopted the most of the technique called analog to digital conversion and vice versa. Those analog to digital conversion is a mathematical model which has some disturbance. Again, our illumination change which will happen that object. Due to that, the analog to digital conversion mathematical model, there is a kind of noise will be inherently introduced in the video that is called salt and pepper noise. You might be also heard speckle noise, right? SPECKLE, speckle noise. Speckle noise is will be obtained due to the multiplicative factor, right? So there is a lot of mathematical involvement happen in the conversion of this data or acquiring the data. So there is a multiplication factor will be introduced. So due to that multiplication factor, there is a noise will be introduced called speckle noise. So these are the popular noise which will be there in most of the image processing techniques. For that for that denoising model has to be developed. The noise will be the noise will be very difficult to very difficult to face them, and it is also very difficult to denoise them. So that's why they will have to be, there is a very difficult challenge to face them. So unpredicted motion of the object, right? So you may be you may be observe the particular scene or particular frame of the video. So there is a suddenly small changes will be happening. Maybe, for example, the severing of the tree branches, right? Severing of the tree branches. Maybe you can see some of the marriage videos and all, that the kids will be suddenly move out and came into the scene, right? So there is unpredicted motion will be there. For those we need to be addressed. That is flexibility in the object shape, right? Some of the objects will be they will be change their shapes, right? So some of the rigid bodies, some of the rigid bodies may not change. Maybe metals may not change that body. Even if some of the bodies which have elastic power, so they, after hitting some target, after hitting some strong objects, they will change their shape. Maybe due to they will change their geometrical shapes. So those are also challenging issues to need to address. Transformation of 3D world into information into 2D, right? So natural world is a 3D maximum, maybe beyond that also. But today's some of the instruments are going to be occupied or capture the 3D information. But our most of the machines and most of the other knowledge base would be deal of the 2D, 2-dimensional. Definitely there is a information loss which will be happening here. There is a mapping mechanism has to be taken place. Due to that mapping, there some of the data has to be lost. So that will be happen also. So occlusion of the objects, right? Occlusion of the objects should be overlapped with the other objects. As I said that point tracking. There we can have a feature point. We need to be keep reference. So that feature point we need to be observed in the next frame. So what is that frame? What is the relation between this point in the first frame and point in the second frame? So this relation has to be constant or grow. If the relation will be decreases, then that is a one witness we can say that occlusion of objects might happen in the scene. So complexity in object shapes, that is also the huge challenge. That is most of the artistic the shapes will be very the irregular shapes. So those shapes are going to be definitely challenging. That is changing illumination. Changing illumination is a permanent problem for most of the object tracking ideas, right? So definitely that will be going to be changing illumination is a very difficult factors. We need to be look after that in a special way, right? So camera motion. So camera motion, we can see that the camera motion may be it might be that pan camera, PTZ, right? Pan is before that we can have zoom camera, zoom in, zoom out, right? Front and back. So pan camera, so about the axis left and right, right? So tilt camera, that is a top and bottom, right? PTZ camera, you know that. So those portions are also going to be a challenge for us. So in what motion they are adapted to when you capture the videos and all those points we have to be look after that. So having understood these challenges, definitely we maybe build some models here. So track that is a problem scope here. So there is a one camera, there is a static background, assume that single moving object. So there is a complexity when you have multiple objects. One camera, static background, multiple objects. So the one camera, the dynamic background, maybe camera may move. There is a single object or multiple objects. So this we can solve either either with the help of the we can build a model, or we can go for the trajectory of the motion of the objects, right? So here I am going to be discuss some of the topic related established or experimented with help of the model building, not the trajectory one. So number of sensors, that single or multiple objects with a static background or moving background. The complexity will be keep increasing, so that problems. So today's effort to track a single or multiple objects in an image sequence with a single camera in a static or dynamic environment, right? We'll see that. So again, we can encompass some of the image processing and pattern recognition techniques to identify that track that in a spatial or spatial or frequency domain. So normally it is. So benchmark data set, you can see that. So normally we need to be, as a researcher, we want to publish the papers or publish our articles. So we depends on the publisher. So for frontier publishers always look after the benchmark data set, right? So the benchmark data set is a one called IEEE, right? So IEEE you might be heard, that is a PETS 2001, right? PETS 2001. So that performance evaluation, tracking and surveillance. So this 2001 data set, it is available in the website, so you can take it that is, right? So there is a ball sample human beings, then there is a car and there is a call and bicycle. Similarly, there is a taxi, right? So there is a DT any meter. So this database which will be snowy falls, that is. So we have 2001, that is to have some dark, right? So then first of all, ball is a little dark, that is. So these are the standard data sets are available, and we need to be defined that frame size. What is the frame size? 240 into 320, right? 240 into 3, whatever size will be there, we need to be normalize that. I normalize it into 240 into 320. So number of frames, there is a 60 frames are there. So out of this 50 remarkable frames have been experimented here. So there is a contents, the ball, there these contents are there. So background is fixed, right? So whereas in the pets, pets, all those we have, there is a dynamic background. So the camera is moving. So challenges are the irregular motion. The ball is a irregular motion. So that will be oriented when moving. No? During movement, that even that whatever circle formula, whatever that sphere formula may not work. It changes shapes, right? Size increases. There is a tree movement in the camera here. So again, there is a illumination in PETS 2001 and PETS 2001 bar 3, right? So there is a slow and fast movement will be there in the visor database. So there is a dark object in the background. So we can observe that. So there is a snowy scene, as I said that. So these are the benchmark. After performing that experiment, we need to be check that potentiality. So that potentiality you can check with help of the yardsticks called some of the formulas. We need to be as I told that human eye is a qualitatively track the motion of the objects. So the machine have some limitations. So that the qualitative analysis of tracking performance is observed by the visual analysis. That is a very accurate one. Quantitative one we can observe by the some of the mathematical experiments. That is a true positive, false positive, and false negative. So on that is. So moving object detected regions are small in the true positive, right? So where the wrong matching object is called the false positive. So matching will be a true positive, wrong matching is a false positive. So that false negative will be a bounded box, unbounded box, neither fixed in the decided object or background object, that is a false negative. Similarly, other we have recall and precision, false alarm rate, and also we can have geometric and F measure and G measures. So those are the metrics or exercise to understand, measure the similarity between the two groups or two set of data or two objects in the longer sense. So there is a recall formula. So we can see that precision and accept combined ratio, and we have a F measure. So that is with help of the precision recall, we'll go pick up a computer. So one more alternative one, that is a G measure, that is a geometric mean to understand the similarity between those models. So the spatial domain, frequency domain, so there is directly operate on the pixel, as we see that. So there is a photo, that image, and that is a matrix. We have XY coordinators, and that point will be need to be identified. So that point will be zoom, that is. So that point we can say that there is a pixel intensity, as we told, the point which will represent the objects, right? So that is a pixel intensity. The intensity is low, that is a dark. Intensity is high, is a towards that color. If we are talking about the red color, the intensity is a 0, that is a black, and the intensity is highest. So that is a reddest of the red. So in that case, gray also. So 78 is a highest color, the bright color, right? So similarly, the frequency domain analysis is indicates the how signal energy can be are distributed in the range of frequency in the object. Frequency range, right, distributed for the object. So there's the spatial domain, it will be look some waves. So but in the frequency domain, it will be look at the corner. No? There is a point is there, that is a spectrum of that object, spectrum of that information. So this column we can have. So here we can represent that is a the point at the circle, right? Circle, no? which is complemented here and there. So that will be a spectrum we can see at the corner place. And this spatial domain we can look into the frequency domain, and this spatial domain you can see at the domain in the opposite corner, which is the spectrum of that which will get located center. Then located at the corner, we need to be center to see that spectrum, which will be understand able how that range of frequency just over that image. The low frequency at the corner we have seen that. So after understanding this, we can see I developed some models with help of research color that is routine, NCCR mean shift, color optical flow, and frequency domain. We have frequency the descriptor, and the revered concepts also extended. Ultimately, you can see how the results are obtained. That is. So there is a background subtraction. So one simple algorithms are employed. So we need to be compute the background, the frame of that, remove the background. So we can take the sum of the frames average, and we can subtract with the current frame, and we'll get a background window. That window we can check with the threshold. So threshold will be more than threshold, then we can keep that. So similarly, we can routine, we can perform, we can obtain that subtract the background, which will be available. Similarly, frame differencing. So obtain the difference of the successive frames, we are able to find that is. So that is a frame 1, 2, 3, so on. That is. So this frame subtracted will get that image, and finally differentiating them, we will get a the foreground of this image. So that is one. Similarly, we can have a correlation. So the correlation will be establish the relation between the pixels which will be present in that current frame and the next frame, so that we can take a cross correlation, and after we need to be normalize them. So there is an image, over the image we can kernel, or we can fix the window. So this window will be in place over this surrounding the center pixel rather than the surrounding pixels. So you can see the simple small example, 1 into 1. So this one and this one, 1 into 1. So like this we can compare this 3 cross 3 and this 3 cross 3. Ultimately we get a 7, right? So this 7 will going to be occupied by the new value will be replaced by, earlier it was 1, now will be 7. So due to this cross correlation, the current pixel, the present pixel or center pixel will be influenced by the surrounding pixel that will going to be replaced. So this kind of mechanism is going to be exercised over this PETS 2001, that is and PETS 2001 and 2, that is the database that is exercised over this algorithm. So we may obtain the results. So that results will may be in terms of that is a true positive and direct relative, and we have a CR, that is a F measure, G measure. So we can see, for example, background subtraction, that is a PETS 2001-3. So that is we have F measure is 33 and G measure 33. So F measure is a yardstick which can exercise that actually in 0 to 1. So 0 is a 0 is the smallest one, and 1 is a maximum, which have a exact accuracy, more accuracy. 0 is a less accuracy. So that 0 to 1 is converted into percentage wise. So 33%. So we have background subtraction which have a less accurate compared to the other FD, right? So you can see that frame differences keep improving. The next we have normal cross correlation is have been improved drastically. That is 41, right? So we can observe this 33, 40, 37, 41. So similarity will be improving, that is. So background subtraction will be because it is a huge competition will be involved. So most of the frames will get involved in mutations. So lot of time will be consumed for the memory usation. So the memory is similarly FD required little improvement. Similarly, that is FD have little improvement. That is last computation compared to that. Statistical formula, that is a cross correlation formula, which have cross correlation the edge over the other two techniques. The BS and FD they are not compatible with NCCR. NCCR is a powerful, we observe that it is a correlation will be established from frame to frame. So similarly, we have FRESH 2001, which have a little improvement. That FRESH 2000 the database is the brightest database, right? Whereas the 2001 is some little dark, because all these techniques are depends upon that major challenge what we observe, that is a change in illumination. So change in illumination which have that reflected here. So FRESH 2000 database is good results have been produced by all three methods compared to the earlier one. Frame database have more information, motion, object, less dynamics in a background scene, right? So hence better than BS, that is. But nowhere that NCCR is not comparable. NCCR is a very strongest technique. That's over both technique which have the BS as well as the frame differencing is rolled out that is. So these results we have been improved with help of the other samples, that is called what is that we can have the well and sample that other than the standard database. So other than the standard database, definitely those standard non-standard or local database which were ball and sample, which you shown the good results obviously. So that is the F versus difference we can observe here. So some updating criteria through the normalized, that is. So earlier we have seen that we have not updated the knowledge here, right? As and when comes, then it will be following, that is the current frame will be depends upon. Now we can make some little smaller, we can build some cumulative process. So that will be update some the target one. So that whatever the knowledge we acquire, so that knowledge we can engrave in the matching that earlier day information also we can take into consider for the computation. The performance has been enhanced, that is updating the template at a suitable interval of frames. So for example, avoid dripping in a tracking, right? So there is a small changes in the motion, sudden changes, the change in illumination. So those who need definitely updation. Training need to be enhanced or upgrade our knowledge base. So there could be NCCR, PCI, histogram regulation line we can use for the upgradation. There is a PCI that critical component analysis which have the highest invariant for most of the this one, that is. So techniques we can have that partition image separate matching through the NCCR and updating a procedure. So NCCR that is also we can exercise more exhaustively, or we can partition the the image and we can exercise there. So we can see that exhaustive as well as the partition effort, how it will be the result with as a histogram regression line we can exercise to produce a result. So these are some literatures we can observe. Out of this, we observe the gap in the literature. Tracking system for rigid object not noticed. Adaptive template matching is not exercise, limited to single object. So these are motivated us to go further. So this we can exercise that the exhaustive image or partition image. So we can have an algorithm for this. So we can maybe it is available. So we can go to based on threshold. We can understand the binary form and all those. So finally we get the results. We can see that. So there is a F measure is 76 and G measure is 78, right? So 76 for this FRESH 2001 3, that is. So the plots we can see that. So we can have the recall is a high, recall is a DR is a recall. So we can have precision will be more, that is a FRESH 2001, can observe that. So similarly the exhaustive one. So the methodology through the PCA that is the earlier one, and PCA updation which shows a little improvement, that is 89 and 88. So the regression line we have with the help of the Euclidean distance. So minimum Euclidean distance object is announced the greatest match, and same will be replaced in a new template, right? So there is a regression line will be exercised here. So these formulas are exercised to find the regression lines. So regression coefficient will be there, so that we can find the histogram of that. So again, the tracking algorithm, there is a tracking and updation will be taken place. So the performance of tracking with the NCCR and XRL update will be there. So again, that database will be there. So we have that database. We can see that from the patch 2001 and 0, 2000 and 2001, and we have rewarded that the results with the 95 percentage of that F major we can observe. Obviously, it depends upon the true false. The true false increases the F major or G major how you improve that is. So from the bar chart we can visualize more pictorially, so that we have F major how highest improvement. So the partition image exhaustive, we have done the exhaustively for the complete image. So we can split the image into partition. So those partitions we can exercise or experiment over this various techniques, the NCCR and the measures are PCA, regression line, and so on. That is right. So we have that updating has been carried out through the NCCR, PCA, and HRL object, that is. So acquisition of the partition image we can perform with help of the fixing the window over there. So this window will be moved towards this X direction and Y direction. So ultimately we need to be operate this kind of acquisition over the partitioned image. So that have been repeated for most of the partition. So partition image with the NCCR and update. So update with the PCA and HRL, right? So NCCR itself is also as act as a updating. So PCA and all those. So relative we can see that. So for FETS 2000, the exhaustive template matching will be have 76, 789, 95 for histogram regression line. Similarly, in the case of the second data set also, the same outcome will be there. For partition template, so we have 83, so little improvement there, and in HRL case definitely improved, right, F measure, and similarly you can have that 2000, that is HRL is 100%. So these are all 100% is definitely tough to say because it is all empirical and spatial domain, right? So empirical, these are laboratory results. So we need to have build a model, mathematical model to verify this thoroughly, right? So this again, that is a other way we can represent with a bar chart. We have NCCR, and there is a frequency component, principal component analysis. Again, we can see that PT 2000, 2000, that is a partitioned image. 2000 have good results compared to the 2000 and 2001, right? So these have computation. So HRL is the highest one, as we seen in earlier. Definitely, that is the largest the template and the tracking is better as a conclusion. Or we can have some inference, empirical inference, which have depends upon the template size. The F is extremely super for histogram regression line based template updation, right? Especially exhaustive, and for both HRL has potentially exhibited its performance. Cumulatively, that we can see so far, we have seen that background subtraction, frame differencing, NCCR, so on, that HCL, right, PCA, right. So all these methods we can see that definitely the monotonous increment happen in the case of NCCR, HRL, as we just observed. For other database similarly, and coming to the mean shift, we have seen that mean shift which will be in the kernel model, as the classification is there. So most of the objects we can access with help of the histograms, right? Mean shift tracking through the color model. So efficiency definitely might enhance with help of the color coherence vector. Then literature we observed. Here literature says that search window adapts itself with the objects. So that motivated us. So make a more adoption or updation which will be happen in the previous algorithm to improve the distinction between the background and target, right? So discrimination, the clear discrimination should drawn. So that will be that kind of effort we have to incorporate in the subsequent discussion. For that mean shift vector, so that is a vector we need to be we will be see in the subsequent discussion, or maybe it may go through in some of the most of the image processing pattern exam books. That is well elaborated there, these signatures and mathematical formulas there. So I may quickly move towards this. The number of points observe that that is adding the points which are represented by 2D vector. 2D vector. So we can vector can construct that 2D vector is divided by the total number of points, right? So this points will be subtracted with the initial vector. So we'll get a signature. So that mean shift vector always points to the direction of the dense of the point data points, where that is it go towards the where the denseness of the rather than the sparse, right? It never go towards the sparse distribution. It attracted towards the dense points which will be accumulated in the scene. So the joint histogram, for example, histogram we have our knowledge. The joint histogram we can generate for this. So firstly we can see that histogram y-axis and histogram about x-axis. So this amalgamated and form a joint histogram. So this joint histogram is also going to contribute most of the information. I'll find the motion of the object in a scene. So for example, you can see that there is an object here for which we can have a target model we can build. So we can have an object displacement here for which we have a target candidate will be calculated. It have a different histograms, right? So for this we can have a density function, and we have a density function for this target candidate. So jointly we can say that the similarity function we can compute to have a mean shift for that is. So after getting the mean shift, that we can build a color model for that target. So target is represented by ellipsoidal region, right? Ellipsoidal region. So image normalization unit, because this ellipsoidal region, you know that it influences by the what is that target scaling. In order to avoid this target scaling, we need to be shift into unit circle, where that unit circle may not entertain that what is called scaling. Even that entertains based on the simple formula, we can able to rectify that or reformat that. So that's why it will be converted into normalized unit circle. So this unit circle region is centered at 0. This probability of this future target we can model by histogram, that is a kernel K. So this we can have that right. So this is a corroborative function will be multiplied. So this will be K. K is a what is that, K number of kernel. So these are the samples, right? So these samples will be normalizing constant called C, right? So this normalizes that converting into ellipsoid into unit circle by multiplying this factor, and it will be K number of the kernel will be there, kernel bins will be there. So this kernel will be summation will be multiplied with a constant factor in order to have a unit circle. The kernel has a convex and monotonic decreasing kernel profile, right? So this small weights will be which will be noticed that the pixel which is away from that center, no? So those pixels may not visible or may not come in a scene. So those pixels also we can encumber put into the scene. So that's why we need to be convex, that monotonically decreasing the kernel profile, which will be helpful to cover the farthest pixel from the center which is available in the photo or image, right? So target candidate, the profile of kernel is defined the function. So that is 0 to infinity. So we have a kernel here. So this kernel normalized pixels into the target candidates. So the center at the Y in the current frame. So target is model as so this is a P is a probability density function. So probability density function which encourages the random variables, that discrete random variables which will be build a model to construct a target candidate, that is a probability density function p cap of u, that is a y at that center, that is. With the help of this similarity function, this earlier mean shift formula, so similarity functions we can compute either by this Bhattacharya coefficient. So there is a 1 minus rho into probability p of the tension, that is a Bhattacharya coefficient we can exercise to measure, that is a rho is a Bhattacharya coefficient. So for that we can have compute, that is, so minimizing the distance is equivalent to maximizing the rho, that is right. So with a maximize this mean shift, that is a little mathematics is involved here. So I said that the probability density function with the Taylor expansion, and we can see that there is a multiplication will be happen. That is a window, Wi is a window. It will happen, only need to maximize the second term, which is a density estimates with the kernel profile kx at y in the current frame, with the data being weighted by Wi, right? So kernel, we have seen that there is a non-parametric iterative procedure point, that is, so the density of samples, the n number of samples, and the kernel k. So f of that function dimension, there is h is a frequency, that width of the bandwidth of the frequency. We can say that normally used as a kernel. So appends the QO, the kernel has a profile, that is. So this generalized kernel will be considered, so that kernel we can see this way as a in the domain, time domain. So mean shift convergence with the shift method, that is until converge will be, that is taken from y0 to y1. So convergence will be happening here with help of this formula, where the complement of this for a kernel with a convex and monotonic decreasing, as we told, to cover some of the pixels which will located at the far away place from the center. Such pixels also we can maybe in order to put it to consideration. The entire algorithm is will be explained here in the steps here. So I may go to the definitely results here. So we can see that the results that F measure we have fetched 94, whereas the DT any winter is a 65, because this is a snowy videos. So this have a lesser one. So we can observe that F is here. So CR is a recall. Recall is a definitely depends upon the false positive, sorry, true positive. So the we have good results will be obtained. We observe the top is 2001-3 and DT Winters database. So improvement over this the earlier one. So we can have a color coherence. So color coherence, that we can have some coherence between the neighboring pixels. So that relations we can encash here. So intensity of the image. So we can convert them to color code. No, that band. For example, band 1 contains 10 to 19. Band 1 is a 10 to 19. Band 1 is a 10 to 19. So whatever the 10 to 19 are there, that will be 1. And similarly, to 20 to 29, 2. 30 to 39 is 3. So ultimately converge into 3 class. So these 3 class we can labeled into connected component. No? So there is a 1 is A, like that we can replace. So we'll get that is a label A, B, C, D, E, color 1, 2, 1, 3, so on. That is size is 12, 15, so on, that is. So color scores vector will be formed here. So this tau is equal to 4. The color scores factors we can have, that is here. So we can obtain, that is. So with help of this color scores factor vector, we can compute that with help of this algorithm. So we may able to get a result that is a F measure, which tells the similarity between the two events or two pixels or two objects which are present in the different frames. So that have a 95% of relations will be established. So obviously with the pictorial bar chart will be more elaborating. And joint histogram, as we seen that X direction and Y direction. So concept also we can extend it here. So I will run this algorithm. So maybe we may get a performance of joint histogram over this different data set. All 4 data set we consider. So we have a 98, sometimes PET 2001 is a 100. 100, right? 100 is a F major. So bar chart again, in other words, you will be explained. Relative performance, you can see that. So there is a PES 2001 which have for that color coherence vector and joint histogram. So three methods are exercised, and similarly the second data set color there is joint have shown the 100, and we have a 2001 that is a joint one maybe less here compared to the other database. It depends upon the illumination change in illumination of that video. DT winter, we hope that we have seen that it is a environment is snowy. Of course, we have bar chart will be explained. So CCV and all those. So cumulative summary, you can have that definitely this joint histogram and CCCV adds over other earlier algorithm. Similarly, for second data set, joint joint histogram, which is excellent, right? Of course, it may be some of the earlier results are jumbles. So I hope so far we covered some topics, that is the some of the things which will be able to track the object. So depends upon the time I will be continue. I hope request coordinator if any the interruption. I will just send some signal. I will stop, that is. Otherwise, I will keep continuing. So I will go for one more work, that is a optical flow with HRL and iris distance. So optical flow, it will be find the point at the frame, and what is the point at the frame and within the image, and also it predicts the where that point could be in the next frame, where that point could be in the next frame. So that kind of mechanism will be exercised by the optical flow, right? So here the tracking performance has been exploited. Harland and Sung and Lucas Kennedy color optical flow schemes. So those are the very old and popular algorithms. Even today, most of the practitioners have been adopted those algorithms. So before going to that algorithm, we'll see that the optical flow, the region extracted in the reach in the information. So could be three planes, red, green, blue planes. So updating the template through the obviously that other regression and dilate distance, and the combinations maybe Lucas Kennedy with the help of this regression and dilate, Harn and Sunk with the regression and dilates, right? So you can see that optical flow principal concept, that is consider the point at the frame 1. So similarly, that point will be moving compared to the all other frames, that is, right? So okay, with respect to the time that the point is moving in the frames, right? That is a video sequence. So sequence of frames. So we can amalgamate them with help of the formula, that is a change in y and change in x, delta y and delta x. So this image is combined, right? So this is a part of the image, but at the given instant we may see only frame 5, right? But the complete image will be combined like this. It will be visualized. So it works at a pixel level, not at the object level. So flow calculates the velocity for a point within a images, right? So the point appear in the first frame and the second frame and subsequent frame, so that they have some motion. So that motion will be measured with help of the vectors. That is a velocity vectors. So point will be that extra the information will be there in the vector, that is called the velocity vectors. So velocity vectors are generated for every frame, right? So that velocity vectors will be provide the information of the displacement of the points in the frame to frame. It is an estimation of where the points could be in the next image, next image sequence. So for example, you can consider frame 1. You can see here. So there is a one column after here, the frame, the object is here. So see the second frame. It is moving, no? It is moving. It is moved the two column here. it is moved to 2 column afterwards, right? It is a horizontal movement. So for this optical flow, you can compute, right? So that is, so this velocity vectors are the represented as a arrows, right? So optical flow, which helps the velocity vectors represented as the arrows. So those are the it is towards the movement of the object. This velocity vectors, which have a direction as well as a magnitude. So this will be represented, and it indirectly shows the object is moving in a forward direction. So from the frame 1 to frame 2, we will be able to understand the optical flow, that is a velocity vector. A velocity vector will help us to represent as the arrows. So this arrow shows the optical flow of these two frames. Next, we can take frame 3. So the frame 2 to frame 3 difference, we can see that the optical flow will be in the diagonally downside, right? So this velocity vector will be, so in terms of the arrows, which shows the flow in a diagonal, downward diagonal direction. So we can easily understand how the optical flow will be influenced or compute accurately to estimate the displacement of the object in a different frames. So blurred image, definitely blurred image, as a we have seen that the challenging is a change in illumination. Changing illumination is one problem. The other problem, objects or images are themselves naturally blurred. For example, you can see chameleon. I told the example that camouflage. Camouflage, that is a net, green net for the military camps. They posted over the certain height. So that will be create some commonality between the background and the object color. When the object and background are similar, definitely that objects will be hide or obscured or lost in the scene. So for such kind of object is very difficult to find out from the whatever the smartest camera we have, that whatever the highest resolution camera we have, that. So blurred image, that is unidentified as a still pictures become ununderstandable once the images are set in a motion. Having blurred image or having the same color as a background, if they are moving, and definitely we may definitely find it difficult to find the displacement or motion of such objects. So here the optical flow definitely gives some information, but have, that is a inherent curse. Inherent curse, that is the very challenging factor, that is change in illumination. Change in illumination, even what in any algorithm what we discussed so far or available literature, every research are fighting for that to provide a good solution for that. Of course, optical flow mechanism provide the solution, but it is a suffer from the change in illumination, the challenges. So which may especially relevant as a source of visual information in the people with a low vision. People have low vision, so for them it definitely such subjects may invisible for them, and definitely that's why the camera failure to identify that. So in this direction there is a literature happen. So there is a color optical flow estimation happen. It is the first time we have seen some of the work. Color information results, color based approach provide a high assessment. So this high assessment motivated us to proceed further. So comparison between the gray scale and two color methods will be definitely there. This we have movement of fire and temporal intensity variation and spatial color, and all those will be help us to motivate to exercise the optical flow mechanism in order to estimate the motion of the object in a frame. In a larger sense, we want to track the object which may be available in the scene, that is in the scene, that is. So there is a little mathematical involvement is here. So I may go faster. I hope I told that is available in the book. Little modifications I have done for our experiment purpose. So that I will skip, that is. All else I will go faster. So flow vector in the image space. So there is a Taylor series expansion has adapted, that is a delta t. So we have that is the image x comma y comma t. So x is the x direction, y is the direction, t is the time, right? So 3 dimensions are there. So their change will be adapted, that delta x, delta y. So that is, so that going to be with a partial derivation. So we can find that is u comma v. So u comma v is a that is a directions of that optical flow direction. So optical flow vectors. So we need to be convert into I comma x comma I comma x comma t into I comma u comma v t. So that is the x coordinators where u comma v comma t is a velocity vector directions and magnitude. So that for kind of in order to derive them, there is a simple mathematical modification which will happen, which is available in the book. So I may go, that is, we need to be convert them into u and to v form. So the brightness and the brightness constancy equation, we need to be find them. So there is a formula. Horn and Sunk, I told, and Lucas and Carday have contributed a lot in that direction. So those have modulated, reformatted these optical formulas in order to address little the challenges that is called changing illumination. So that energy function and minimization. So we can have that is conversion. So with error estimation. So that will be differentiate with respect to U and V, not to convert into U and V form. So we can have that is right. So this is Laplacian and Horn and Sunk ultimately brought into U and V. It relatively compute U and V. So those are the velocity vector of that pixel. Assuming the initial U and V are 0 and U and V are going to be average after getting neighborhood. So here we can have a Kewer plot. So Kewer plot, it is a mechanism which help us to show pictorially that velocity vector into arrows, velocity vectors into arrows. So that will be, we can observe here. So there is object identified, and that velocity vectors will be so here it is moving in the either direction. So that shows the arrow. So corresponding gray plot, we can have a color plot, right? Color plot. So from this we can have a number of pixels versus number of frames. We can have that, right? So gray color which will be just the more number of pixels, that is gray color. So which will show that image contribution for which we have a Horn and Sunk, and with the station that is called histogram regression. The level we can see that is lines. Horn and Sunk I have with the HRL is a 99 for this PETS 2001 3/3. Obviously Haber taxi have lesser even for exercise for this optical flow, right? So that optical flow mechanism, Horn and Sunk, that is and we have that is a plot here. We have seen that obviously taxi have lower F major, that is a similarity. Lucas Carday, it have a higher response compared to the Horn and Sunk. So there is a modification which will be taken care by Lucas Carday, and that will be exercise where that the illumination change will be addressed to the little extent compared to the Horn and Sunk earlier exercise. That is a define energy functional derivatives equals to 0. So rearrange and construct the observation matrix. So that will be find that partial derivation. So maybe there is a mathematics involved here. So this Lucas Carday will be converted into this UV form. Then the here UV will be there. So we have results can obtain, that is again Kewer plot shows that the velocity vector movement towards the objects move. We can understand by the frame difference, successive frames. So that can indicate here two objects are there, interested objects. For that identify that is gray flow and the color flow. So for which we have plot versus that pixel versus the number of frames we have exercise. So we have a that is a red one which have that is a color one. It shows the edge over the blue one, that is a gray. So gray which is the attacks the less number of pixels. In other words, the color one will be address more color pixels. Definitely it shows the edge over. Maybe 3 components are there, RGB. So the together definitely it enhances compared to the gray. Of course, the computation complexity is very high. So for the color one, so we have a Lucas Kernel successive frames into 3 channels. So previous frames and current frames. So that estimates the velocity vector for all 3 frames. So we have computed the individual channels through the threshold and merged them, right? So all 3 channels are computed with help of the some threshold. We can merge them. Threshold we can obtain with help of some of the earlier papers are based on the visualizations of that the object in a scene. So morphological operators may be closing, opening, or maybe erode and dilations have heard. So those are exercised to make a more accurate visualization of the object in a scene of that moving object. So structure knowledge base and the spatial information also have considered or taken into account. So we have HRL for template which will be given good results, that is. So Lucas Kernel we can have, that is HRL for 99 compared to the all earlier algorithms we have experienced, that is. So Horn and Sunk optical flow that dilate distance for the curiosity to adjust to experimentation tested with a dilate distance instead of HRL, right? So dilate distance is also one of the prominent computation formula which is available in the literatures, which will be mean and standard deviation. So from this mean and standard deviation, you can find that template. So dilate distance. So the distance between the considered and the target one, we can make it and find the similarity between them. Right? Again, that algorithm, the same algorithm repeated only the dilates we have exercise here instead of the HRM, right? So the performance of the Horn and Sunk for the dilate distance, we can observe that there is a drastic improvement. Maybe you have a Horn and Sunk definitely dilate distance as per the curiosity we have seen compared to the HRL earlier experiment, right? Of course, we are see that the maximum we observed for 2001, 99 for 2001, that is maybe brightness of that the illumination changes may be less there. So proposed algorithm Lucas Kernel dilate distance brought into this a complete algorithm. So there is images exercise for the different images, that is Lucas Kernel with help of the DD, right? So definitely there is a improvement we can observe. The overall results we can see combining that histogram and the dilate distance. So individually you have seen the combined one we can see here. So there is a F measure. So there is a F measure. F1 and F are similar. So the little computation depends on the applications. Here I exercise the F measure. So you can see the F measure for this both 3 data sets. So this complete one, that is cumulative results, you can see that, right? So this can be up to work 3, that is. So excuse me, sir. So I may take one more work, sir.
Sir, as you wish, sir. Up to you, sir.
Okay, sir. I will take one more work. So so far we have seen that the optical flow, NCCR, and some of the basic routine methods. Now you can see some of the little enhancement in view of improve the results, in view of improve the classification results which happen in the computation of the motion of the object in different frames. So descriptor base, that is a safe signature, right? Safe signature we can build, that is the signature may be 1-dimensional or 2-dimensional. Normally signature may be 1 dimension. So that signature we can exercise here. So we can build a signature. Maybe we can borrow some earlier algorithm. So the earlier algorithm we have seen that optical flow based on the Horn and Lucas Kernel, that was exercised for 3 channels. It is computationally expensive. Of course, we may get a good results. But if you worrying about the computational part, so that polynomial behavior of algorithms, that will be more memory expensive, right? So here we can reduce that burden to the little extent by exercising the Fourier descriptor. Fourier descriptor, as you know, that it is a range of frequency which will be distributed over the objects, so that the data we are going to be collected over the with help of the descriptors. So these descriptors which will be template as moving object are computed. So Euclidean distance I have seen in the previous maybe similar to the Dirichlet distance. It is again the alternative one. Euclidean distance, the Minsky formula, maybe some of the Manhattan city block, maybe several the mathematical formulas are available to compute the similarity between the two data sets or two group of data. Here the Euclidean distance are exercised here, so which you can see that for computation as well as the application. So we have seen that many yet the detector. Maybe a simple algorithm, maybe you might have heard that is Sobel, Privet, Gaussian, some of the simple algorithm you might have heard. So apart from them, there is a additional canny edge detector which will give the more edge information compared to the all other algorithms. So canny edge detector we can take into consider to build the shape signature, acquire the edge with the optical of the object with less noise. So this one shape signature we can construct. So that shape signature position, point, edge, curvature, area function, centroid. So all those kind of shape signature also we can do. But here simple typical shape signature with the Fourier descriptor. So we can have that is. So there is a Fourier functions are there. So boundary functions, edge functions, so centroid functions. So these functions we can make use to construct a shape signatures. So basically we are a Fourier descriptor. This is a frequency domain descriptors. So that area function, right? Area of functions, curvature functions. So we can exercise these functions. We can build a Fourier descriptors. So we can have a small one that is a Fourier descriptor. So I hope you know that there is a complex conjugate that Fourier, the Fourier first Fourier transformation computation. You might have a little experience. So you can exercise those Fourier transformation over this signal that is A of n. That is a array which have points which will be there present in the object or maybe in the target, right? So that 2D conversion we can have from that is 2D. That from literature we can understand or motivate there is a success in proving the supremacy of Fourier descriptor. So there is a we observed the literature which shows that improvement from this Fourier descriptor. So locating especially logos in the image database. So you might be see the database of the image logos. So their exercise there prominently, which have provided the very good results. So that with help of this Fourier descriptor, so geometric mean segmented centroid signature going to be computed. So that is a x and y. So number of segments will be there. So we can have this R relation. So that is R is the absolute value of this nth segment. So we need to now compute that. So at the end we can have a vector, that is a vector. So this help of the equation, Fourier descriptors are enumerated making the invariant to rotation translation scaling. Invariant to rotation translation scaling, right? So that rotation invariant, scaling environment. We have seen in the previous that the kernel was what is that ellipsoid. The ellipsoid converted into unit circle. So there that what we observe that target scaling was there. Target scaling might influence us, no? So that kind of influence would not change the results. So such influences we need to eradicate either way. This kind of rotation, translation, scaling invariance we need to be eradicate them. So this happened here in the GMSC, that is a geometric means of segmented centroid distance function. So the algorithm will be built, that is. So this algorithm we have exercised over here. So there is a results obtained. There is a signature either boundary, edge, area, centroid and all those, right? So F major you can observe here. So very F major less for the boundary, 30, right? 13 was there. The highest one is the 82 for the centroid. So that is the absolute one. So centroid have high centroid signature. Sorry, centroid that Fourier descriptor. Centroid Fourier descriptor for the model to observe the motion of the object in the frame, which shows the highest, that is the F major, the similarity is more, that is. So here from the again the bar chart says the centroid for the absolute data set, that is a F we can observe, that is. So that is a Fourier descriptor, as we seen, that is a powerful, which was the highest, as we see in the earlier algorithm. Of course, it is a frequency domain, right? So some data need to be processed with the frequency domain. We have subsampling, that k invariant, that is you can take the points of the signatures, k points. So k points, the number of points of the signature, that that is a Fourier descriptor. We have that the more points may not show that, even for less points also show that result 57, right? So again, it is a bar chart. So convention centroid and proposal, we can have a here that relative, and it shows that is results, and with GMSC with result centroid for other data sets. For the other data set, we can see that. So centroid GMSC shows the better one compared to the centroid one. So the 98 it has a edge over the centroid compared to the results, that is. So cumulative one, we can see that. So from this, definitely we can have edge over at the rightmost. We can see that the Fourier descriptor centroid, the GMSC, that geometric mean segmented centroid, which have good results over for the other compared to the other database. The cumulative one have been observed that dramatically increasing, but at that color and color cohesion, there we have little the downside. Depends upon that the computation, that color velocity vector have shown that represented that motion of the object in a scene, that. So maybe I have a last work, that is. So I will go faster, and I will just show the results, and I will wind up, that is. So here we can have discrete wavelet and lifting discrete wavelet with help of the standard deviations. So we can have that lifting scheme is an emerging strategy, less computational complexity, and simple mechanism. So here exercise the 3 levels of decomposition. So those are the predict and updates, that is split predict and updates and phases will be taken place. Of course, that is a AWT is decomposed 3 levels. So obviously literature has increased, that is us with multiple moving object are identified their color, especially from based on the frequency domain, the discrete wavelet transforms, right? So I may go faster, that is a little mathematics is involved here. So I may go to the directly results. So we can have a 3 frames. So we can get the difference of this after decomposing, and we can binarize them and uni them. We can exercise the motion mask and exercise the connected component in order to establish the relation in the neighboring pixels that weighted standard deviations have computed, and that will be used for that template updation, and find the results, that is. We have LWT, that is we can have that 100% F major compared to the third level of chunks works, which is a simple DOT exercise, and third level normal one. So compared to all this, we maybe for our data set, it has produced the appreciable results. Of course, that is relative results with this. We can see that for different data sets. So we can have no significant improvement for third level DOT, that is with chunks. So whereas the WSP LWT has a superior. So whereas the computational aspects will reduce nearly 50% with the lifting based DWT compared to the classical DWT. So the eventually with the WST, so edge over the chunks approach, which is the third level DWT. So we can compare the results, that is, so we can have approaches here, backward subtraction, frame difference, and correlation. So we have, that is, so we have grown up from the routine methods, initiated from the routine methods, which was initially not encourageable results. And we extended the correlation, partitioned and exhaustive. So there we have improvement. Even then, our strive will be continued for the mean shift. We have. So mean shift will be, it is a, we have seen that regression lines which contributed rather than the contribution, which I have seen the classification of the tracking methodology, that is a point tracking, so that mean shift is exercised with help of the that histogram computations. And optical flow, we have seen that optical flow, which is a velocity vectors, the velocity vectors which will be where it is there, what is the relation within the frame, and how it could be possible in the next frame. So kind of mechanism will be provided by optical flow. Horn and Sunk and Lucas Carnaday have provided that. So it is produces the good results. So finally, we have seen the signature, that is a Fourier descriptor, either with a curvature or maybe various area and mechanism exercise. So there we observe the centroid has provided with the modification of the centroid, that is a green geometrical mean segmented centroid, which have also contributed a little towards the improvement. Finally, we have the lifting discrete wave rate transform, which are provided. So this is another way. This is the other way for all approaches for a particular data set. Earlier, that is 2001. This is for 2000, and we can have that comparative analysis of all the methods for various data set. So maybe the normal non-benchmark, maybe benchmark data set, and above that. We are seeing in the alternative way to represent that the improvement performance. So that we can observe here the results here. And so these are the spatial domain till that can Fourier descriptor. So afterwards, that is Fourier descriptor, and we can have, that is what is that wavelets, and how those comes under frequency domain, that is a range of frequency spread across the object area that we are going to be considered as the So there is a affects inference. We can NCCR performs better than frame difference, as we see. That cross correlation, especially with the HRL, is the best combination. And also the joint histogram, it build credibility. So Lucas Carnaday and compared to the Horn and Sunk, right? Lucas Carnaday shown the very good results, which are powerful powerful potential to observe the change in illumination can to update with that to improve the results, that is, and our discrimination is better compared to the other. So proposed algorithm, that is a signature that Fourier description that GMSC has corroborated the significant movement in the tracking performance compared to the centroid based shape, that is. Eventually, we have seen that chunks work and normal DWT. So LDWT has shown with what is that weighted signature, weighted standard deviation is going for updation. So comparative analysis of work, there is illustrated relative analysis of the tracking performance of the proposed model. There is also definitely the feature works will be there. So occlusion we need to be addressed, that is. So due to the overlapping or it's going from overlapping with other objects or similar color and so on, that is. There is also shadow cast. The shadow will be generated from the object itself, will be another reason. So we can have an object, there is a light source, and from this object there is a shadow will be created. So this is a cast shadow, right? So this area will be able to produce the shadow. So this kind of objects will be rushed into the scene or frame of the that reference, for which we have to consider the decide the special treatment. There will be a lot of research is going on in the literature, so that we can take some of the research projects. That is, multiple cameras could be employed in a grabbing of objects or to get the exact shape of the object, which helps the 3D object tracking, right? So in order to build a complete scene or the complete video, for which we need a multiple cameras. When multiple cameras are there, there is a overlapping area and objects overlaps and multiple shadows will be created. So definitely that is a 3D to 2D is a challenging one. So there also the complex process has to be taken place. That is a kind of thing. So these are the some of the reference the publications happen. So my PhD student, Dr. M.H. Sidram, have contributed a lot in this development of the material. He got a PhD from University of Mysore in the area of image processing and pattern recognition. So with his effort, maybe I may be able to present a material here. So there is a lot of reference we have gone through, so more than 130. So maybe I will stop here for the audience.
Thank you very much, sir, for covering the topic in from all the spectrum. It is a very huge one, and the credit goes to your experience to put all the aspects in very concise and structured manner. Thank you very much.
Definitely, sir. My humble request, this presentation, if somebody taking some research work, at least they could get some link, get some logical flow, and various components have to be addressed, so that it become a complete one, and it may be worth to present somewhere, or it may be worth to get a grant also. So in that sense, I may be interested to. I presented all the work which may be available in the that PhD work, sir.
Sir,
Okay, sir.
Now I request our participants to ask questions if they have anything in their mind. Yes, Biswajit Maharana, please.
Hello, sir. Hello, sir.
Please. Biswajit? You can ask. Please ask.
Hello?
Yes, go ahead.
Sir, I am audible.
Yes, thank you, sir, for this wonderful program. I would like to one question I have. Sir, suppose
Your voice.
audience with the help of object tracking.
Okay.
Biswajit, you are not audible properly. Can you type in the chat box? You are not completely audible. Can you type in the chat box?
Hello, sir.
Now it is yours. Please go ahead.
Yes, sir. I want to know, sir, suppose in a conference hall, number of audiences are there. I want to track the number of audiences by using object tracking. So, sir, can it be possible with some basic level of techniques?
Okay. Yes, sir. Sir, you are mute. Sir, you are mute.
Okay. So definitely it is possible, Biswajit, for which a lot of resources are available. For example, OpenCV you might have heard. OpenCV, one of the open source softwares are available. So we can download and we can put it into the system with a little the manual we need to be follow that, and with the installation it's definitely possible to track the object, which is what we said, it is a non-rigid object, it is a little motion well object. That objects we can definitely find out with help of the open source OpenCV.
Yes, sir. Yes. Thank you, sir.
Mohini Prasad Mishra, please go ahead with your question.
Yeah, good afternoon, Professor Nagappa, for this wonderful session. Normally we hear like Gaussian noise. We input this Gaussian noise into the image, and we see that how best our model is getting rid of this, right?
Definitely.
And what exactly actually a Gaussian noise is, and what are the other types of noises are there, which helps us in refining our model?
Okay. So Gaussian noise, definitely it is related to the sensor circuits. Sensor circuit of the camera. Camera may have different component. One that is a sensor, which will scan the object. So that sensor circuit model we need to be understand. Correspondingly, we can build a Gaussian denoising model to overcome the noise, which is a unwanted electric potential which will be rushed into our images. So we need to be understand some of the models. Those models we can inject over them and we can remove the noise. It is a kind of the part of the pre-processing technique. Hello, sir.
Is it something related to Gaussian distribution, sir?
Gaussian distribution. That core formula is there. Gaussian distribution core formula. That is again maybe you might have heard HMM and all those Gaussian mixer models. So those are the initial one, that Gaussian frequency domain.
So like this, any other noise systems?
Definitely. As I told, that is a salt and pepper noise. You might be heard. Salt and pepper noise normally says when you go for a Xerox something or scanning, that noise will be introduced. More suitably, you can say that there is a camera might contains the analog to digital conversion circuits, and the converse is a digital to analog conversions. You may be FM radio, no? You have seen the FM radio. So that analog to digital conversion is happened. So those conversions are the formulas, mathematical formulas. So those mathematical formulas will be again maybe fluctuate due to the change in illumination. The fluctuation happen. So those formulas might have inherent problems. So that most of the latest cameras which may be adopted the very competitive algorithms. But we don't know, we are not much aware about that. So maybe we have to face that this kind of noise. And also we can see that speckle noise. Speckle noise is a multiplicative noise, multiplicative factors. So that formulas which will be involved some of the multiplication factors and some of the squaring and all those. So there, due to that multiplication, ultimately what is the junction of this noise will be introduced. Definitely it is a capturing, and next capturing we need to be convert them. After converting, you have to put it into the knowledge base, right? So where the transient phases are here, capturing and conversion. This conversion might definitely is the mathematical build model. So again, it is a human build model, right? Of course, it is a mathematical proof. Those models are also inherently contribute to produce the noises. One kind that is a salt and pepper, speckle noise, or maybe various other noises are there. There is thousands of noises are there. For that corresponding denoise model has to be built. That is, you might be heard that one IIT professor Yadda Narayana have built a model where the noises are there. The noises he considered as an information. From that also he shown some results. The noise, the complete eradication of noise is not our objective. If we completely eradicate the noise, we may lose the the invariant information which is represents the objects. So that also we have to keep in our mind. To certain extent, we can derive inadequate noise, which is in our purview, or it may be possible to remove with the existing mathematical model available in the literature.
Okay, okay. Thank you, sir.
Thank you very much, sir. Any other question?
Thank you, sir.
From other participants? Vijay Kumar Gowda, you want to ask an?
Yes, sir. Yes. Good afternoon.
Good afternoon, Vijay Kumar.
Yes, sir. You have told that three type of object tracking. One is the point based, other is the kernel based, and other is the select based. My question is, for image processing, which one is the suitable?
Which one is the
Best one?
So we can address in various ways. Again, we have seen at the frequency level as well as the spatial domain. Spatial, most of the spatial domain technique directly operate over the pixel, whereas the frequency one may be operate in the different domain, brought into the different domain and all those. That is one possibility, inherence. Second possibility, definitely the cost of the algorithm we have to think. Complexity of an algorithm we have to think, right? So normally we may think in a prior based complexity and posterior based complexity might be studied in analysis of algorithm. So most of the general algorithms are addressed by the prior analysis. Most of the online softwares or online solutions which you have, which will be address the posterior analysis. Posterior analysis depends upon the what kind of machine you have. So what is the memory? What is the kind of processor you have? So all those aspects we have to keep it in mind. Depends upon the solution. Depends upon the problem strength. We may possibly extend. That is one side. The other side. So most of these algorithm point based and that is a model based. That is a what is that kernel based. So these two algorithms are dominantly practiced in object tracking, maybe due to this complexity or the memory utilization.
Okay, sir. That kernel based, what I think better support method. Is it support?
Yes. Kernel based, basically, as I told, this is for parametric motion, right? This suits for parametric motion. Parametric motion, you might be know that the object may move towards the x direction, y direction, and also z direction. So whereas the other two algorithms, point and the seal out, may look after only x and y direction, right? So this one aspect might keep in our mind to select the kernel mechanism to exercise for the object tracking, right? So if non-parametric motions of the objects are existing in the scene, I don't think the what is that kernel-based mechanism may not suitable, right? Suitable, that is.
Yes, sir.
Okay, thank you.
There is another similar question from Bhagya Lakshmi Devi. She asked, what is the best technique for object tracking in real time?
Okay. So real time we may go for now. You might be heard that is YOLO. YOLO is the most the prominent and dominant software or package the program is available for traffic monitoring. So they might definitely exercise with help of the what is said that what is that kernel based, because it has to be see three directions of that object movement. So the kernel based one is a forward and YO, LO have practiced the kernel-based object tracking mechanism, and most of the open source also available in the directions. So we can download and we can practice them, and we can also enhance them.
Thank you very much, sir. Now, Shraddhanjali Nayak wants to ask you. Please, Shraddhanjali.
Good afternoon, sir.
Good afternoon.
Good afternoon. Thank you, sir, for such an outstanding discussion on object detection, sir. So my question is from classification, sir.
Okay.
So what happens when we are applying different types of classification algorithm on different data sets? We find there are some misclassification, or sometimes the classification not happens properly. So my question is that, sir, if can we implement we can use the algorithm of object detection with classification algorithm or something kernel-based algorithm so that the classification accuracy can be improved?
Definitely, it is I can address in this way. That is a lot of theoretical aspects are there, and a lot of experimental aspects are there. This theoretical aspects to help you to a certain extent. Again, it depends upon the data set. That's why the researchers, we need to be understand the either side society expects something the magic. The other side we need to be obey the rules of the publisher. Maybe Springer, maybe elsewhere, maybe IEEE, so on that. So they won't agree some gully database. They won't agree our own local database, right? You wrote an algorithm and experimented for the local database, they might not agree because they are the frontiers to publish your articles. And it is interwoven with the thesis, right? You need to publish the article, then only you will get a PhD or will get some publications. So they have standard database. Similarly, I went in that direction, and also I may suggest to the student community go for the benchmark data set. So one such benchmark data set is a performance evaluation tracking and surveillance 2001 and 2000. Those data set we consider. So you can go to the first decide the data set, and the classifiers are plenty. Definitely again spatial and frequencies are there, and obviously the complexities will be there. And again depends upon the offline and online solution problem you are going to be providing, solutions you are going to be provide. So based on all these angles, we collectively decide the classifiers, or else you want to excel in the classifier itself. You want to build a smart classifier, that again is a separate research. You might have heard ISI Calcutta. Our frontiers, they have developed a lot of models for the classify the numerical data. They have very frontier in the numerical data, not for the video data, or maybe nowadays maybe they might have done, I don't know. But earlier they have lot of classifier they have built for the one-dimensional data at the two-dimensional data, mostly numerical data, right?
Yes, sir.
So in this angle, I want to pose this question. We want to stipulate only object classification. So again, I need to be consider the database. So what database? Maybe animal database, maybe geometrical shape database, irregular geometrical shape database. So it varies. Whatever the smartest classifier you have, definitely failure in front of the oblique shape database, right? So for which other pre-processing you need to technique we have to develop, that is, as you said, one that is SVM is a very smart in, that is high dimension data, especially outliers. Outliers you might be heard. Isolated data which never club into or mix into any other group. That is a two-class problem or multi-class problem, right? Especially multi-class problem, even two-class problem also. Some data never mix with the class 1 or class 2. It will be always so it's isolation. So such data is also relatively addressed by SVM, one of the oldest classifier which is available.
Okay.
Sir, another question from Samir Patra. His question is, sir, can you give us one real-time example of object tracking used in India?
Oh, definitely.
Object tracking used in India.
And definitely object tracking, maybe traffic management, we have seen the traffic. And most of the your supermarket we have been enjoying daily. Supermarket, no? Supermarket, maybe any supermarket you go there, definitely is there. And most of the airport almost have object tracking solutions. Airports, even now today railway stations are also extended, right? So plenty of algorithms are there, right? Which even they connected to some of the, I told that is some of the cameras, I told only fixed camera. There is a camera, maybe aerial camera, maybe a satellite camera, right? So those also incorporated and taken into help. So definitely, maybe most of the airport have covered the object tracking mechanism and traffic management.
Sir, can the drone camera images be helpful for object tracking?
Definitely, those cameras also can connect. Nowadays, that is also research is going on. So those cameras also, aerial cameras, aerial cameras maybe comes, and maybe your filmmaking, some of the cameras at the some track cameras also there, right? So track cameras that multi-dimensional, maybe pan with aerial, pan with track, right? Pan, I don't know, that is a pan means pan, tilt and zoom. So those properties are inherent along with this other vector. So I told even that space guard. So there are huge cameras are watching our globe in spite of the on behalf of the entire country, on behalf of the entire globe. I have my any other the planets may be rushing into hit the Earth. So there is a space guard. This is the latest technology have been developing. People have contributing. Most of the developed countries are looking into that space guard. That definitely those are drone camera, or beyond that that is a satellite camera.
So there is another question from Satabdi Palit. Now the question is, what software we can use to build kernel-based model?
Oh. There is a small softwares are available. That one example that OpenCV I told. So I'm not confident about the software. So we developed the model with help of the MATLAB. Nowadays the Python is also very good. Python program, a lot of functions are there. With the Python functions, they can build their own software. Algorithms are readily available. Even codes also available. We can borrow them. We can build them. Maybe Python and Android is the best choice now.
Thank you very much, sir. Thank you for taking time answering the questions. Presenting is a really wonderful presentation. Now, I would like to request my colleague, Dr. Subhendra Kumar Jaising, to propose a vote of thanks.
Oh, 1 second, sir. 1 second, sir.
Yes, sir.
1 second, sir. Before that, I am very much grateful to the Director CDC, Biju Patnaik University, Odisha, Rourkela, and also my special thanks Principal, ITMT Katak, Professor P.K. Pari. With their support, I am able to share my experience, and also yourself, that Dr. Rai Guru Akshay Kumar Das. Really, he is so interested and talked many times to establish this presentation. And thanks to Professor S.K. Jaising also maybe witness this program. Once for all, thanks to all. They given the very good support to share my little experience with budding researchers of this institute. Thank you, sir.
Thank you very much, sir. Now I request my colleague S.K. Jaising to propose a vote of thanks.
Thank you, sir. Good afternoon, all of you. Honorable Principal, Professor Prabhat Kumar Pari, Head of the Department MCA, Dr. Ayaguru Akshay Kumar Das, revered speaker of today, Professor Nagappa U Bhajantri, all the principals and the faculty members present in this webinar. I feel it privileged to express the vote of thanks in this auspicious occasion. It gives me immense pleasure to express my heartfelt thanks to our revered speaker, Professor Nagappa U Bhajantri, Government College of Engineering, Chamrajnagar, Mysore, Karnataka, for sharing his experience and knowledge among all our faculty members of Viswanath University of Technology. I hope this knowledge will be very much helpful for all the faculty members, researchers, the PhD scholars in future. And on behalf of all the faculty members and participants of this webinar, I request our revered speaker to give some time in future to talk on some more topics. Thank you very much, sir. I am very much thankful to our Honorable Vice Chancellor, BPUT, Professor C.R. Tripathi, for taking this initiative for organizing this FDP regularly for all the faculty members of this university. Really, this will be very much helpful to all the faculty members and indirectly to all the students of the university. Special thanks goes to our Director of Curriculum for coordinating the webinars regularly. I am very much thankful to our Principal Professor Prof for giving time in spite of his busy schedule. I am very much thankful to our Head of the Department MCA, Dr. Revered Das, for coordinating this webinar, organizing the Google Meet and accepting the applications from different participants and coordinating with the revered speaker. Last but not the least, I am thankful to all the participants, principals who are present in this webinar. Thank you all.
Sir, before we depart, I have just I want to something now decided, because this is a very wonderful session and it is very interesting and it is purely research based. I think if this recording will be published in the YouTube. Sir, do you have any objection, so that the
definitely you can do, sir, no problem.
So that now I request my the fellow friends, colleagues, that I will be uploading it in the YouTube, so you can go over and over again. And if I will be very grateful, and will think if you take up research in this field, we will be really will be privileged, and will think that our effort could result some really fruitful thing. Thank you very much.
Once again, that thank you for Jai Singha and the audience, especially audience who participated. They might be participating due to their own interest or force from the institute. Anyhow, thank you once again, once for all. Thank you to everybody. Thank you, sir.
Participant, please fill up the feedback form, and the certificates will be given to you. No problem in that, but fill up the feedback form. Thank you very much, sir. Thank you. Thank you very much, sir. Thank you. Well, I will be in touch with you, sir. Thank you.